my channel. In this session, I'll be covering our today Kubernetes session. Let me quickly set it up. There was some power outage, so give it a few minutes. And while that happens, do let me know from where you're joining and any queries you might have, feel free to ask. Okay, let me quickly set it up. Okay. I hope you guys can see it. Do let me know if you guys can see it. And okay, hi Sandeep, is there live session? Is there? Yeah, it's here. So yeah, you can ask any questions during the session. Just setting things up. And also do let me know if you guys can hear me, if you can see the screen and everything or not. Okay, that's very crucial as well. Okay, now let me quickly start sharing. Okay, I see that everyone joining, and it will be quick session. It's just a simple starting session, like very fundamentals I'll be covering. And do let me know what kind of experience you have, if you already know Kubernetes or you're completely new on it. So it will help me to conduct the session. Like I should be go through very slowly and basics, or I can go in speed. So do let me know that part. Okay. And while that happening, let me quickly check. Okay. Hey, hey Sainath. Hey Kalyan. Okay. So 2 days this session actually got forwarded. One for my child was not doing good, and same time my wife was not doing just earlier day. But yeah, finally it's happening. I hope you guys like it. So yeah, first thing is that Kubernetes. What exactly is Kubernetes? I think many might already know, and whoever don't know, I'll be going through that exact same point. So let's go one by one. You guys already know about me, so nothing to say on that. But still, I'm a lead DevOps engineer for not just single but multiple companies, and as well as doing practice. Even if I'm not working for a project or a client, I do experiment a lot, and I hope my experiences, my knowledge, my all this fact and knowledge I've gathered will be helpful for you guys. Okay, that's why I'm conducting the session. Okay, so first thing first, what exactly is Kubernetes? Now, um, prior to Kubernetes, you guys already have tried some containerization. If not, I will suggest that go try it out the basic containerizations such as Kubernetes, Cryo. There is a lot of like Missions or some kind of tools are there. There are a lot of tools, but yeah, most popular is the of course Docker. So if you guys don't know what is Docker and what is that, I will be not covering the Docker part here. But yeah, feel free to go and check out the Docker part. It's really easy. If you guys can, I mean, want, you can go my check my around 3 or 4 year old videos on Docker, or you may go to take all Nana's channel. Her channel is really excellent. Or you may just go to the free code camp. There have a Docker full length videos. That also you can now refer to. Okay. Now exactly what it is Kubernetes, right? I mean, you might have this Kubernetes word here and there in the different interviews, or maybe your friend talking about if they're working on this technology. But what exactly it is? Okay, we'll be going through exactly that point, and of course, what are the core components of Kubernetes? What are the basic concepts you might have before starting the Kubernetes? And of course, this session will continue each week. I'm targeting at least having one session. Hopefully, my family member, if do well, I'll be able to. Otherwise, we never know. Life is already uncertain. Okay, so yeah, let's get started. Now, what exactly is Kubernetes? So, Kubernetes is a powerful open source containerization tool or container orchestration tool designed to help us manage microservices, containerized application across a distributed cluster of computing nodes. Now, what exactly is the computing nodes here? Computing nodes, you can call it your computer, laptop, or machine, or EC2 instance, or in other cloud other instances. So any you can say any type of instances, be it Linux, Windows, whatever OS has. Okay, Kubernetes is supported in every single kind of OS, so that's not a problem. So yeah, we might run applications throughout distributed cloud. Distributed means what? Suppose one instance is in AWS, one instance in your on-prem, one instance in your say GCP. You can run anywhere. Like you can manage centrally and you can deploy anywhere. That kind of architecture you can easily get. Now each cloud actually what happens that each cloud provider have its own solution. Say for example, AWS have its EKS, Google have its GK, the Google Kubernetes solution. So every cloud provider have it. But if you are thinking about that, okay, one cloud may go down, I should have some already, you can go for that also. Not easy but achievable. Now Kubernetes main you can say main point was to manage the containers. So what happens normally that if you have Docker containers, the Docker application running in by the Docker continuation, the problem is that you can manage one, you can manage two, you can manage hundreds normally. I mean that's 100 is also not humanly that possible, but you can, if you try, you can manage. But what about the 1,000 nodes or 1,000 containers? What about the container communication? What about the containers dependency, self-healing, say auto-rotating, or whatever the complex use cases that you might can see in the normal business cases? What are those cases? What will happen? How can you handle those kind of cases? That why and what? How can you handle this big or this huge workload? And of course in different, like you need to have a scalable solution that can scale throughout the multiple instances, multiple resources and all, right? So that kind of requirement was there. There's a reason why Kubernetes was born, to help us in handling the container orchestration or container workload, okay, in a distributed manner. There's a actual view of it. So Kubernetes is nothing but just a tool that help us to manage the containers. That is the simplest definition that I can give to you guys. Okay. Now the next part, that the using Kubernetes you can of course automate many manual tasks involved in deploying, managing and scaling configuration. Now why saying that? Because say for one application you have assigned say 1 GB RAM and around 2 CPU. Now there is certain workload happens. Okay. In normal cases, you can see most of the cloud provider give you the auto scaling and all these tools, right? So Kubernetes can actually, of course, it have its own inbuilt solution, but it can also integrate with those kind of solution that cloud service provider provides, and it can scale the application according to that way. Okay, so that's another plus point. Now Kubernetes aim to hide the complexity of managing containers through the use of several key capabilities such as REST APIs and declarative templates that can manage or that can help you manage the entire lifecycle. Now what happened that in the Kubernetes, to manage the configuration, like what exactly you want to run, how you want to run, that you can define. I mean whatever you define is going to run exactly that way. Now how you want to define that? There is a YML file you have to provide to Kubernetes API server. Now I will be coming to the core components, and don't get confused. Just think about that. You are giving one file to Kubernetes and saying, please match to this state or have this kind of requirement ready. And Kubernetes will do make that ready if it has the resources, of course, to spare. Now that kind of thing will be, as soon as we go through all the slides, we'll be discussing on that. And I will say keep your questions coming, no problem. I'll be going through. Let's see if already have some questions. I will come. There's one good question that Yusuf asked: what is the best GKE, AWS EKS, or like other maybe cloud providers? So I'll be coming to that one. That's a very good questions. Okay, and yeah, it's a complete beginner level. That's I'm starting this series. It's a zero level. Okay, you don't have any Kubernetes knowledge, fine. But I expect at least to have the kind of basic Docker knowledge. Otherwise, it will be like if I start Docker part, it will become unnecessarily big. Okay, that's the reason I want that. Okay, now let me go through. I see one question that Kiran asked, that can you please explain the architecture and the ports communication and the network flow lifecycle? Yes, I have dedicated. I'm going to have the dedicated session on that. This is a 101 session, just some Kubernetes architecture view, some what are the basic components are, why is that, like kind of basic question and answer. Now, as we go forward to next session and all, we'll be covering more in-depth topics. Okay, but I'll keep a note of that. Okay, I'll just make a start and this question so that I will cover that one in my upcoming sessions. Okay, so now let's go to the next one. I hope you guys understand the basic concept. Now you didn't master the Kubernetes, but think Kubernetes is such a tool that will help you to manage your containers. Containers in the sense Docker containers or any container engine you use, that kind of containerations. Okay. Now, why should you actually use Kubernetes? I think I already explained that one, but let me repeat myself again. First is the scalability. I mean, should you run orchestrate containers on across several host machines, uh, physical like on-prem, virtual like AWS EC2, Google computes or say Azure computes, wherever you run, you can run it. That kind of scalability will get by the Kubernetes. I mean, there are other tool, of course, but Kubernetes is one of the best one. I mean, that's the reason the people why it's like so eager to implement, so eager to introduce Kubernetes solution in their architecture, right? That they have the reason. Of course, we'll be going through. We'll understand what is the reason, everything. Okay. Now, next thing is the production ready. Now, what is mean by the production ready? That we can fully implement and utilize container based infrastructure in our production environment using Kubernetes. Also, we can optimize hardware usage to make sure most of our computing resources. Now, prior to even containerization, what happens actually that in suppose you have 4 CPUs and say 4 GB or 8 GB RAM. If you run single threaded application, it will run only single threaded, right? It will not run, it will not use the entire CPU, or it will not use the entire RAM, right? So there are kind of resource wastage was happening. Okay. Now, yes, container, normal container itself help us to recover a lot of that. But again, you cannot handle that well, all these kind of things. You cannot you don't have the flexibility to manage all that without any container orchestrator. Now, Docker itself have their own solution. Docker Enterprise, they have Docker Swarm and all. But again, somehow it disconnect from the real world usage, or that simplicity it didn't able to achieve. That's the reason we have this tool, we have this popularity of Kubernetes. There has to be a reason, right? Why otherwise people would have used the normal Swarm or something else? Why they're running after Kubernetes? Because it's much flexible, it's more community accepted, it's much advanced facility. Okay, so that's the reason. So yeah, it will help you to reduce the wastages. You will be, suppose you have 4 CPU or whatever CPU and whatever RAM you have, you can fully utilize for your production environment. So zero wastage you can achieve via the containerization itself, and even further via the Kubernetes. Now, flexibility. So we can declaratively manage services to ensure that deployed application running as intended. Now, what exactly that means? Suppose you want that an Nginx application or say any Apache application should be running fine. Now, how can you make sure it's running fine? Like you have to make sure, right? You need some way to make sure that Kubernetes have their own health checking. It have its own provenance and every single thing that you can manage to make sure that my application running fine and all. Those you can implement really easily with Kubernetes. It can dynamically mount and add storage to run stateful apps. Stateful app in the sense that the data that you're writing or doing operation, that should be saved somewhere, and in the event of anything like say pods destroy or say even any container destroy or anything happens, the data should be saved and recoverable and can be reusable. That's kind of stateful apps. Now, that's one part. Now, do health checks. Of course, I told you in the beginning itself. It do have its own health check mechanism. Enable application for self-healing. Suppose one container, or not say container, one pod gets shut down for any reason. It could be anything. It should automatically roll out a new pod, and it should be serving the request automatically. Okay, if it's healthy or not. So those kind of mechanism also Kubernetes have in place. We'll be covering all that advanced stuff, let's say in our next session, but just understand the basic stuff. That's the goal of this session. Okay, now like history, like you cannot skip history. You have to learn how all the things progress and how the things going on. So that's why a little bit, I know it's sometimes boring, but let's go through that. Okay, and let's see any questions so far. So yeah, that's how is the daughter now she's fine. I'll be coming that maybe in the end. Okay. Oh, okay. So no further questions and all good. Now let's proceed. So yeah, first it was the name of this Kubernetes was not Kubernetes actually. Okay, it was something else. It was called Borg systems. Okay. Now, why was that? Like it's what is that kind of internal tool for Google people to manage the clusters. Okay. Then it's a story of course started at 2003 and 4. Now in 2013, see what is the huge timing they have used and then they have utilized from 2003 to say 2013, 10 years. Like 10 years they have used for them. They tested, they grown, they run their application, the Google search, this and that, every single thing. Now they thought, okay, it's kind of getting ready. Let's but before actually like introducing to the other people, they name it Omega. So booked Omega on 2013. Now I think for some reason or any reason, I'm not the Google engineer, so I cannot tell exact what reason, but they have some articles, some speculation on that. You can of course go forward. So what they did, they in 2014 they named and released this project instead of Borg or Omega. They give the name Kubernetes. Okay. Then in 2015 they like have an agreement, or they created the CNCF, that is already know that cloud native foundation one. Now, and they of course released the Cube version 1.0, or Kubernetes version 1.1 in 2015. In 2016, they go mainstream. Like people actually started to use, or at least start testing out these solutions. They're like, okay, I saw a new framework, or I saw new tools that's now available in the market. Let's give it a try. Let's understand how it works. Can it be useful for our application architecture? All those kind of questions the user getting have, and they started using it. In 2017, it actually got the adoption or enterprise adoption. So big tech firm, you can say like let's say Tinder, say I think a lot of other companies also there. I think if I go and on it, this big name like Google, of course, Amazon, and this big company Facebook and all, they already started using that one. But even normal small companies or medium companies also started adopting the Kubernetes. Okay. Then in the 2018, like then because in 2017 people actually started using it. Now big cloud providers find out, okay, there must, I mean, we have to also cope up with this technology. We have to make release of manage this, like a managed solution, say manage Kafka, manage instances. Similarly, a managed Kubernetes solution you should be providing, and that's a huge scope. People are actually going forward to that. In 2018, GKE, EKS, and AKS they have released. Now think about that. All big company first they have kind of migrated to Kubernetes, so that started running their own workload. They kind of perfected it. They make sure that it should run for their, like normally it should run normally for the normal customers, or not against their end customer. They have released it. Now at the release it will be not perfect, of course. There will be some problem, this and that. Of course, over time, like from 2018 to already 2022, they have a lot of improvements, and they're still improving. Kubernetes is releasing new versions, as and of course this GKE, UKS, or AKS, or any standard Kubernetes solution, they should be automatically kind of incorporating with the new changes. Okay, that has to be happen, because there's a kind of certified Kubernetes solution they are saying while giving these tools, or giving say any service, GKS, GKE, EKS, or AKS. They're saying a certified Kubernetes solution. That means whatever Kubernetes give, or say any tools, any feature, they has to also adapt to that one as soon as possible and start offering to the customers. That kind of thing going on. Now the story continued, of course, because Kubernetes is still evolving, still a huge word, still in very huge demand. People still learning, still finding out things, and it improving, of course. So yeah, it's a story continued. We don't know exactly where it's going, but it's whatever is going for good. Okay. I'll be coming to architecture part. Let's see if any questions. I will check once. Okay. Okay. Bare metal and cloud containerized organization. Yeah. So one question that Munir had, that they explained between basic differences between bare metal and the cloud containers. That one I'll be maybe covering in the end. Okay. Let's see any other questions. That is a good one. Okay. Thank you, Rishabh. Okay. Now let's see any other questions or not. Otherwise, I'll just simply continue. Okay, so let's continue. And let's see my camera charged or not. I was actually hoping my camera get charged. So no. Anyway, it's fine. Okay, let's start. Continue with this one. Okay, so now I think, I hope you guys can see it, because this is very very crucial, and you guys can see it. It has to confirm. So yeah, do let me know if you guys can see this architecture, because you guys have to understand this really well. Okay, why? Because that's have everything. At least the overview part, it's have the everything. Okay, so first thing, that in Kubernetes, of course, think of like any software, any tools that you want to run, you need a machine to run it, right? Let's say Microsoft Office, let's say your say any, they say your webcam or any application for say a browser, right? You are of course installing that in a computer and then starting using it, right? Think about Kubernetes. I mean, it's also another software, it's all another application. It has to actually kind of, it has to run somewhere, right? I think let's do one thing. Make me- Okay, so that has to also run somewhere, right? So that somewhere is the nodes. Okay, now what's node? Again, it's a computer only. Nodes in the sense it's a some computer, one, two, five, could be any number. So ultimately some multiple machine, a single machine. I would say normally it's one master node and two worker nodes. That's the minimum requirement for Kubernetes cluster. Okay, so let's say three computer running, and out of which one is the controller node and two is the worker node for this architecture example, or in general any normal or simple architecture for Kubernetes. Okay, so what does the master do? Master say run this one, do this one, like commanding, or say you can say the leader or the commander. It gives the commands, do this, do that, and worker nodes kind of are soldiers, so they will do whatever um, the 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 commander is saying or the head of the army saying. That's what they do. And now, just like command have its own traits and workers or say soldiers have their own traits, similar way master nodes have its own features, own components, and worker node have its own component. Now what does the master node have? It has the API server, it has the controller, it has the scheduler, it has the key store value. And what do the worker nodes have? It has the kubelet, it has the container runtime, and network proxy. Now what all these things, I'll be coming, I'll be going very deep dive, so no what is there. Just understand the architecture first, okay? Because that's the most important part. Now as a developer, like we are a developer, right? We have to handle and manage the Kubernetes cluster, we have to deploy the application, we have to debug it, we have to do a lot of things. And we are as an engineer interacting with the cluster. Okay, now if you have used Docker, you already know Docker command do the same thing, but for Kubernetes also do the kind of similar way. Okay, and here the tools we use or the command we use is the kubectl. Now I will be coming what exactly kubectl, what it does and all that, so nothing to worry. But just understand kubectl is the tool that is used to interact with the Kubernetes clusters. Okay. Now, for example, that you want to create a resource, any resource. I'm not telling about which resource. I'm saying any resource. Then you have to tell via the kubectl to the master node. You are interacting with the master node that I want this resource to be created. Master node will get that. Master node will check the operational thing. It will say, okay, I have the resources. Okay, I have the soldier to deploy to this region. Kind of this kind of approach. You think that I have the resources to do things. Master node will check that. It will check that okay, I have this resources. I can deploy this or I can do this task. Then it will do it. Otherwise, it may just give error or it just do nothing. Now, and worker node will simply have the kind of everything ready, that whatever the master node say will do. So master node saying to run this, will run that, whatever the master node says. So this is the basic configuration. Now what are these components? The API server, controller, scheduler, and say in the kubelet and the network proxy will be coming in a deep dive. But in general, again, the master node have its components only for controlling the worker nodes and controlling the entire overall cluster. Whatever you have to do, the master node will handle every single thing. Okay. Now, for example, what happens if the master node goes down? Everything goes down. What happens if the worker node goes down? If other worker nodes are there, the workload we can automatically shift to that. So you understand the dependency. If master node is not there, it got like somehow it's got bad, everything gone bad. Somehow worker node gone bad, you can, there is a way to recover it automatically, or maybe if not automation is not there, you can even manually recover it. Okay, so understand that part. And of course the users, say we have our end users or end clients or customers, right, who will be actually consuming this application, not the cluster. Don't think cluster way. Cluster and all this technical jargon are for us developers. Our customer doesn't know what is technology, what is exactly say Kubernetes, what is Kubernetes, nothing. They know absolutely zero until unless they are engineer like us. So customer don't know all that. Customer will go to a site, see site working or not. If not working, they will say this is the bad side. I'm not never gonna visit it again, right? So that's the reason Kubernetes have this health check. Kubernetes have this, readiness probe is checking that it's have the resources or not. You can implement alerts, you can send alerts. So entire CI/CD things, entire DevOps kind of. So one of the things that Kubernetes is most preferred DevOps tool for deployment and managing the application and deployments. So that's the reason, right? So yeah, we'll be coming to that as well as we go forward. Now, let's see. Yeah. So Kubernetes cluster. I mean, I was talking about the Kubernetes clusters only, but now we'll more jumping to the actual technical words. Okay. Before jumping, let me again check any particular. Yes, Sandeep, can you please explain multi-master cluster configuration? One question that Naresh have, that multi-cluster configuration, actually they are going to be a complete dedicated session on managing the multi-cluster or multi-master nodes and all. Not nodes, multi-master control plane and the multi worker nodes are there. So that I'm thinking of having separate session. Maybe that I will say, explain that way. Okay. But otherwise, too many things, the time will go up. Okay. But I will cover. Don't worry, I will definitely cover that one in my upcoming session. How to make sure that high availability in pods we have. I'll be coming to that, but they have a in like normal sense. Now, if one pod goes down, another pod will automatically up by the Kubernetes. Not Kubernetes, you can say the kubelet or worker node, and this is how it makes sure that we have the capacity to run the application, or whatever replicas it or replica numbers you have mentioned, that number should be running. That kind of thing Kubernetes maintain. I'll be coming to that, so no worry. I'll be explaining in more details on that part. I think. Okay, yeah, I think that's the important one. I'll be coming to all the question later on, but for now, let's continue the session. Okay, so what is Kubernetes cluster? Now, Kubernetes cluster is a collection of nodes, that is, nodes that on the which you run your workloads. And this node can be physical, of course, and bare metal and machines or virtual. Now, bare metals are simple in the sense it's a kind of catchy term that people use, but bare metal in the sense it is normal physical computers. That's called bare metals, okay, or on-prem also you can say. And the virtual machines are the, you can say, what you're running virtually. So there is a main physical layer. Above that there is a virtual layer, and above there you're running the guest OS, okay. So those kind of architecture you can run, and where this is called virtual. So like kind of it can destroy it, you can create new virtual machine and all, just like the EC2. I think EC2 and all the cloud instances are the very good example of the VMs, virtual machines, right? You can just create a EC2 or create an instance, then shutting down, like that one. And serverless, like Amazon Fargate. So for example, you don't want to provision and manage, because any EC2 virtual machine you, or even the bare metal you use or create or anything you do, you have to manage yourself. That if you don't want to manage that one, then I think you can go for the serverless solution like Fargate. Only catchy part here that if you're going to use Amazon Fargate as a solution, think about the cost, because cost is going to be really high. So check your clients have budget for that. Sometimes it may be time and money saving, because you're not managing things and all. If it's an intermittent workload, say for 10 a.m. to 11 you will have the usage, then rest of, say, for next 5-6 hours no usage, then you have the profitability in Fargate. But if it's a 24/7 usage of any cluster, it's foolish or it's just silly to use Amazon Fargate, because the cost will be above and higher than your normal instances. Even you can go for the reserve instance, or you can go for the savings plan kind of that, but not Fargate. Fargate have the savings plan like integration, but it will be still not profitable. Now Kubernetes cluster enable us to schedule and run containers across the collection of nodes. What nodes means here? Worker nodes. So master node again control everything, and you would normally run the workload in the worker nodes. Okay. Yeah. So and this cluster have a control plane, and the control plane actually reside in the master node, and all the worker node, like say all the containers and everything get run in the worker node. Okay, I'll be coming there, so no worry. Let's continue. and I will be explaining that very soon. Yes, I think this is many people actually um waiting to go more deep in the notes part, right? And I was telling that I will explain and explain. So this is where you're going deep dive. So what is Kubernetes nodes? I think I already tell, but I will again tell because it's an introductory session. Even if you have, yeah, after the session done, you have any question, I'll still again answer what exactly is a node. So Kubernetes run workload by placing containers into pods to run on nodes. Now nodes in the sense worker nodes. Okay, and a node may be virtual or physical machine. I'm saying repeatedly because that's a fact. You can run on physical machine, on virtual, even on serverless ones. Like forget. Each node is managed by the control plane on the master node. Okay, contains the services to run the pods. Now, what are the type of nodes? Of course, I think I'm telling from the beginning, but I will explain even further. The master node. The master node controls the state of the cluster. It does scheduling, scaling, and maintenance of the cluster state. Okay, like manager or say the CEO of the company, which manages every single thing. Like whoever the head of, like managing every single thing. And the worker nodes are the components that run the application. So you can say the employees or soldiers, whatever you want to think about. Like imagine something that you might find it easy to learn, understand, and compare with. Okay, for me it could be soldiers, could be employees who actually handle the workload. Okay, so let's say a boss giving or say a manager giving tasks to employees and employees doing the task. Similar thing, master nodes give the instructions, give the actual what's supposed to happen, and worker nodes do that part. That's what it is. Nothing complicated more than that. So the worker nodes are the components that run the applications. Worker nodes perform tasks assigned by the master node. That's it. Now, some tips I think you can say for your CK exams and all, it will be useful. There must be minimum one master node and one worker node for a Kubernetes cluster to be operational. Like that's the minimum requirement. But I would say you should have at least two worker nodes and one master node. Otherwise, you might find issues. Okay, cluster name must be domain compliant because because ultimately you have to actually integrate with the cloud services and a lot of things, right? That's why the cluster nodes must are name, and then even the nodes name also has to be domain compliant. Now, suppose there is a cluster a node that supposed to you might want to run upgrade and all. Again, upgrading part I will have separate session. Okay, no worry on that. But just giving you an example that you want to upgrade a node, any Kubernetes version or maybe any package, or maybe you're upgrading the OS. You want to do that. You have to make sure first that anything running on that particular node or machine should not run anything. It should automatically go to other nodes because I'm going to perform some things and things will break for sure. And in tech, things break even if you want it, don't want it. There is no 100% guarantee things will not break. Even Amazon, Google, Facebook, everyone have the things break all the time, right? So that's the thing. Something can happen, and it's very normal to happen. Now, in that case, you have to make sure the one that you're going to upgrade or say maintain and all, that whatever is running, whatever application is running, it should go to some other worker nodes or other places. That's the thing. You have to mark the particular instance, or not say instance, you can say particular node as a kind of in you can say in maintenance mode. So we call it in the Kubernetes cordon. So you have to use a kubectl cordon node name. Then it will mark that node as unschedulable, and then you can perform your upgrades, maintenance, all that. After you're done, you have to mark again that is again operational. So for that, you have to do kubectl uncordon, then the node name. This is important for your exams, maybe not just exam, for your real life use cases also. Okay. Now we go more deep dive into the Kubernetes. Okay, that is first the marker nodes, master node, and then the worker node. So let's go. Yes, so the master node. We are going more deeper into master node. Again, I hope I'm going slow and I'm not going too fast, even though time is a constraint. But I hope I'm not kind of kind of too fast. Okay. One question I think let's answer: is it good option to self-host? One thing here that it's is it good option to self-host create application in the beginning of project when in development? It's yes. If you are going to like say there is a mini cube and all other tools also available. If you want to try it out, why not? But if you are kind of working for a enterprise application or higher application, I will say it's better to have a development server and try it out there because you don't want the last minute surprises which are more costly. Okay, you have limited resource, limited timing, so think about that. Okay, and of course use infra as a code so that you can create infrastructure in a blink of second or something. Okay, you have to always think about such kind of solutions. Let's see one question. I think I saw a very good question. Okay, this one. So Naga saying masternode also part of K. Yes. So yeah, actually in K's cluster, two things: one masternode and other worker node. That's entire story. Okay. Now masternodes is the controller or the head, you can say, which and the worker nodes are body. So masternode whatever till body do the same thing. So the brain is the masternode and the worker nodes are body doing a lot of stuff. What the brain or master thing, that kind of thing. So yeah, master is a part of K cluster. Now workers also part of the K cluster. I hope answer that one. Any other thing? I think rest of the question I think I will come later one. So yeah, master nodes. Now master nodes, what is that again? I think I have told many times, but again I would love to tell again. So this node hosts the Kubernetes control plane and manage the cluster. Manage the cluster in the sense entire cluster, entire worker nodes. Okay, it acts as a brain for the cluster. As I'm telling, like it gives the instruction to body parts as the body parts, as for example the worker nodes, and the worker nodes will do whatever the master say or the brain says. Now, what are the important components the master node have? First one is the API server. Now, what exactly is the API server? So, it's the entry point. For example, you want to interact with the Kubernetes cluster. You cannot just normally log in into, if you can, but you should not directly log in into the master node and do that. That's kind of unsecure. And it might create some security issues if you do that. So, the best part is that you can use tool like kubectl, which actually a client. Okay, let's say you have Postman or for example SSH or like curl. I think most of you are already used to those kind of things. Think about you are using those kind of tools and interacting with any server API. Similar way, kubectl is a client, could be comparable to your Postman or again the SSH client. So it is a client that interact with the Kubernetes masternodes API server. Now API, of course, you understand some REST client and all. So kubectl simply send the request to the API server, and API server send the response back to the kubectl client. That's how it works. So that actual API server which like exposes the communication. This is the part where the kubectl come and interact with. So yeah, it is the entry point of the gateway for REST and kubectl. It receives all the REST requests for the modification to the pods. So whatever request you are supposed to, whatever the changes you want to see in the cluster, you are sending all the data, all the request to the Kubernetes main cluster or master cluster via the kubectl or any REST API that exposes. And then once the Kubernetes master nodes and API server see it's the authenticated valid request, it do what you're asking for. Of course, after checking it has the resources and the configuration are a valid configuration. Okay, so yeah, it receive all the requests for modification to pods, services, replications. You don't know all this, fine, simply go with the flow. I will explain later. Okay, and other services such as the front end to cluster, and it is the only component that communicated with the etdc. Now what is etdc? I will be coming anyway. You can see in the down it's there, so you'll will go through anyway. So this is API server. It simply exposes the API to the public world so that the clients, you as a developer, me as a developer, can interact with the Kubernetes cluster. Okay, that's what it does, nothing else. But yeah, it's also pass on the request and save the data to etcd. That's the thing. Nothing else will be the bad thing. So it also save the data in etcd, get the data. It also work with other components to make sure whatever is the desired state of the clients, it should be there. Now the next thing is the scheduler. Now scheduler component actually what it does, it schedule the pods to worker nodes. So say I want for, say I have an application, Nginx application, okay, it's running in a single pod. And suppose I want it to replicate to 5 pod. So we have to tell via the API to the scheduler, say I need 4 application or 4 nodes for that because there is huge workload. I need it to increase. You say via the kubectl via the API server. Of course, your kubectl interacting with the API server, and then API server tells scheduler or it simply controller. It forward the request to controller plane, that I need this many number of replication for this pod, and it will make sure that number of pods is present in the that particular worker nodes application. For that particular pods, it has the 4 application that will do by the scheduler. Okay. So yeah, it reads the service operational requirement and schedule it to the best fit for the node. That's it. Does. Suppose one node have the resource to run only 2 node. I have a 4 nodes, 4 kubelet requirement. We can run 2 kubelets in one node because the resource is low, and it will schedule the next 2 in another node. That it can does if it configure well. Okay. Then is the kube controller manager. Now is very important. Okay. It always evaluates the current versus desired state. So for now, again, this replication example that I am running one node, okay? Current configuration is one node. Now I want to make it 4 node. So there is, I want, it has to happen 4. Current is 1. So I have 1, current required 4. Kube controller manager, check what is the current state, that is 1, and what is required, that is 4. It will make sure that the desired state achieve via the configurations, whatever change is happening, it should reflect the change. It will communicate the scheduler to make sure that it will say to the scheduler that run 4 pods in this particular node, or in 2 nodes, whatever it is. Like run whatever is the developer asking or the client asking, do that part. That actually what the kube controller manager does. So it always evaluates the current versus the desired state and check for any change in configuration. So any change happening, it detects it and execute the change. Okay. So if change in the configuration occur, it spot the change and start working to get to the desired state. So whatever the developer, the client, the admin for the cluster want, it's asking via the kubectl API server, and then it will go to the kube controller manager or the control plane, and then it will ask the scheduler to do that, and it will do it. Okay. So that's what the kube controller manager do. It simply evaluates what the configuration or the required configuration. If it's the current configuration is not equal to the required one, it will make whatever is required to match the required configuration or required state. Okay, that's what the kube controller manager does. Now, what does the cloud controller manager does? I think it was when I started Kubernetes, I think very long back. It was around 2018, I think. That time it was a new concept. That time, I think now it's very mainstream, but that time it was new to me. So this is responsible for managing controller processes with dependency on the underlying cloud provider. For example, let's say you need a load balancer, or say elastic load balancer. You're running you're hosting your solution in EKS. You need to have that particular one, kind of say, or 2 load balancer. You need security group, you need your EBS as a persistent volume storage. So you are interacting with the cloud resources. That is actually managed by this cloud controller manager. It checks what are the required things we want with the cloud, and it communicates, it maps the dependencies and everything it does. So it manages the cloud resources. Of course, that requires the cluster authorization with the authentication services. All this complexity are there. I'll be covering very detailed in the next coming session. It's a series, right? So it will go very deep and deeper in the next session, and hopefully I'll have my camera ready that time. Okay, now the final component is the etcd. Now etcd is a simple distributed key value store which is used to store the Kubernetes cluster data, such as number of pods, their state, namespace, and all that. Now if you are very familiar with the development or say DB world, in database there is 2 kind of database. Okay, one is the relational databases and second is the non-relational databases. There are other kind of databases, of course, but which actually consist using these 2 primary database type. Such example like graph database, you have time series database, but we'll not talk about that. It's too many ways, too much distraction. So yeah, mainly 2 type. One is the relation data and second one is the non-relational, the key value store. So etcd is a non-relational database. It's the key value storing database. Okay, like a JSON data you see, that kind of data. So a simple distributed key value storage which is used to store the Kubernetes cluster data. So what are the current you are pushing ultimately in the API server, you're pushing configuration, right? that configuration to save somewhere, otherwise it will get lost. So they need to store permanently somewhere, right? That somewhere is the etcd. It will get stored in the etcd database, or you can say etcd database cluster or database, whatever you call it. There it will store, and it will interact. So API server will interact with the etcd, as I told in the beginning, that API server is the only component that interact with the etcd to see what is stored, fetch it, process it, whatever data. So ultimately the data stored part happen by the etcd, and you can back up etcd, you can restore etcd, you can do a lot of stuff with etcd. That will have a separate dedicated session on etcd in my future episodes. Okay, so yeah, this is the basic components. If you guys have any questions, you can ask. This is the interactive session, and I'm definitely checking that. Okay, so one question: in which scenario we need to take is, yeah, one very good question from the Naresh, that in which scenario we need to take backup. So you are going to say you are upgrading the cluster itself, or you are seeing some you are going to make any data change, or make any minor change or any change that might corrupt the data. Kind of safe side you want to do, or for example your cluster blow for any reason, you need to make sure your data always, there should be always a disaster recovery steps. So you need to take the back of the data for disaster recovery purposes. Okay, because nobody wants things to go bad, but things get bad eventually. You have to make sure whenever it gets bad eventually, we should have a way to come back to previous stage. That back to previous stage can happen if you have a backup, and all the Kubernetes data gets stored in the EDDC. So anything bad happens, if you can't get back to the previous stage, it's a big issue, right? For that reason, we need to have a backup of the EDDC. Okay. Let's see, anything good question. Yeah, I think this one is very good. So can master node and worker nodes be in different AWS regions? Also, how the scheduler for scaling okay, let's see, is different than auto scaling. Okay, so I think that's a very good question, and I will definitely answer that. So can a master node and worker nodes in different AWS region? Yes, it's possible, but there will be latency. Okay. How the scheduler for scaling is different than auto scaling, and auto scaling group used to scale up, scale out. So see, the scheduler part, it's the virtualization of the pods. Okay, or you can say it's maintaining the pods virtually. Now auto scaling, again, it's doing virtualization part, but it's doing with the cluster, the, you can say, the instances or the nodes, worker nodes. So you want to have more worker nodes, then you are dealing with the, of course, if you're hosting the solution in the AWS, then you are dealing with the auto scaling group. But if you are dealing with the pods, the containers, then you are dealing with the worker node itself. So scheduler deal with the particular pods, not with the nodes scaling and all. For node scaling, there is a thing called cluster auto scaling, which is the normal, if it's in terms or in viewpoint with the AWS. If you are hosting your Kubernetes solution in AWS, then it comes to the auto scaling group, which that it will say you need more new nodes, you are getting that via the auto scaling group. If you are maintaining the solution in auto scaling group, you can easily add that one. Okay, so in normally what happen in user data, you have all the script and commands. So as soon as the instance get up on first boot, it will get all the script running, it will automatically join to the master node. Okay, that's what happens. I hope I answered your question. Okay, if not, do definitely ask me again, I will definitely answer. Now today I'm in my home, not in my wife's home, so I have a lot of time. Let's see. No TDC is a non-relational database is there. TDC is a non. Okay, I think maybe he's some answering to someone question. Yeah, EDC is a non-relational database like MongoDB. Yeah, that's what I told. I think maybe someone asked. Oh, I think yeah, it's in us. EDC is a relational. Do we know? It's a key value. Key value is a non-relational database. Okay. Any more questions? Otherwise, I will simply move forward. Yes, I will simply move to the next one. Okay. So yeah, we have covered the master node in very details. Now let's move to the worker nodes. So this is architecture of the worker nodes. Okay. So what it has all coming, but again, just as a reminder, what exactly is a worker node? So there are machine or nodes which host the data plane, or the, just like you can see, if you thinking very in a tough way, controller is like the master node is a controller, and data plane is where like, everything get hosted. That's why calling it data plane. Okay, might be some technical jargon. Just ignore that part, all the technical jargon for the beginning at least. Okay, so yeah, these are the machine nodes which host the data plane, or you can say where the things get hosted, where containers or workloads are getting deployed. Every node in the cluster must run a container runtime such as Docker, but Docker is not the only one. Actually, Kubernetes is trying to ditching the Docker, maybe because Docker is actually kind of somehow it becoming non-open source solution, or kind of as a reason. They have a long reason, you can just read it. Everyone have his own reason, everyone can interpret as a different reason. I will not go there, it might be in a complete dedicated session on it, so we'll think about later. But yeah, at least it should be kind of Docker is still famous container runtime for Kubernetes, always remember that part. So yeah, Worker nodes, it's simply a machine where we run our containers, okay, or where master node instruct to run the containers, or inside run the containers inside your pods, okay. And what are the components the worker nodes have? The worker node have mainly two, or I would say three components, for example, okay. Container, which sends the container runtime. So yeah, first one is the kubelet. Now understand very carefully, in interviews this get asked that what exactly is a kubelet, and if you don't answer that, you're out of the Kubernetes job position most probably. So yeah, this is responsible for running state of each node, okay. It's regularly taking in a new or modified pod specification and ensuring that the pods and their containers are healthy and running in their desired state. This component also reports to the master node on the health of all the host where it's running. So what it does, just as a kind of reminder, or you can say the main points, it simply check that it's resetting every single node or node. It makes sure that whatever pod specification coming is getting deployed, whatever the pod have is like what container port to expose, what are the image to run, those kind of things, a lot of things, right? So it makes sure whatever specification, pod specification you push by the kubectl command, that exact configuration should be maintained or should be pushed to the containers that you're targeting via the selector, okay. That what has happened. Now these components also, I mean, it's check that of course running the desired state or not, but it additionally also check that health of the worker node, okay, like how much CPU remaining, or how much CPU is using, how much RAM is getting used, what are the networking bandwidth, what are the IOPS is have, all this kind of every single metric that you can think of, that is actually checking and passing. Now there are a lot of way to make it enhance, or you can make it more advanced. There are a lot of tools. Maybe in our next sessions I will be covering that, okay. So the next one is the kube proxy. Now the moment you are proxy, okay, think about that a VPN connection. I will not this is a completely VPN connection, but think about that. It normal, suppose you want to skip the sensors and all, make sure that I'm not getting detected, right? Use the it's to work as a proxy, okay. You are using some other machines to communicate with the internet. It doesn't work exactly same way, but it's again the kind of way it also works, okay. I will explain, okay, don't get confused. I will explain in a simple words. So kube proxy is a proxy service implementation that manages IP translation and routing, okay. It works same way as the VPN, but some of course fundamental differences are there, but we'll may talk about that part in our future sessions. Now think simply, it just the communication part happened, okay. A user is there trying to access service, that service where to access or where to redirect that particular request, that happen in the kube proxy. So suppose I want to in a particular cluster there is 5 application hosted. One application is a Python application, one is a say Go application, one is the Node.js application, and the user want to access the Node.js application, and he's particularly entering that particular route or particular URL. Now that will come to the kube proxy, and kube proxy, okay, will check okay, what is supposed to be redirected. Okay, this is the URL key entered, then he will go to the particular this Node.js application. So that mapping, that virtually redirecting or proxying the request, that we are calling the kube proxy. Kube proxy simply translate the IP addresses or the routing to the ports that are supposed to access by for the user or supposed to get used by the users. That's what happens. And such as network proxy, like for example, such as network proxy and load balancer. If you can see load balancer, say if you have an AWS load balancer or any cloud load balancer, you have your target machines or target instances. So as soon as the request goes to the load balancer, you are not directly typing out the IPs of the your Node.js or Python or Go application. No, you're not doing that. You are typing the address in the browser for the load balancer. That will redirect automatically to the particular application that you're trying to access. Okay, so that's happen the same way, right? Load balancer will for using load balancer, you don't have to remember the IP of the applications, right? You are simply remembering the full address or the full domain of the load balancer. It exactly works exact same way. Okay, and yeah, so that runs on each worker node to deal with the individual host subnetting and expose service to the external world. As I say, normal user will be using like try to access the application, then kube proxy will translate like where to direct the request that it does, or where to actually the user want to access what application, that will redirect automatically. It perform the request forwarding to the correct pod or containers. That's what I'm trying to explain till now. So it perform the request forwarding to the correct pod and containers across the various isolated network in the clusters. Okay, so yeah, one pod will may not interact with another pod if it's not in the same network. Okay, network part I will have a detailed session in my upcoming episode. That's why I'm not even covering that one here. I'll be covering in detail. There's a dedicated session on the networking because you cannot just contain in a small session. Okay, so yeah, next one is the container part. Now this resides inside a pod, and the container is the lowest level of a microservice. I mean, in a microservice, one service is actually interacting with other services, and suppose that one particular service where the application is running is a container, like in the container environment. So yeah, this resides inside a pod. The container is the lowest level of microservices which hold the running application. What I was trying to explain. So it holds the main application. Okay, and which now this application which holds like application like container, what you have the application, you have the dependencies like binaries, all the libraries, all the things that you need to run the application, you put inside the image, and that image running form is the container, right? So container have every single thing that is required to run the application. Now container can be exported to the world through external IP addresses, and the Kubernetes have supported Docker containers since the first version. In the July 2016, the RKT container was added. Like after I think 2016, the RKT container added, and now I think there are a lot of container engines available. Okay, and I'll be again have a dedicated session on what are the container engines you can integrate with Kubernetes. I hope you guys understand this. Let's see if any questions, because like you might have a questions. So one question is there. I think let's see. It's in the saying that what actually runtime refers. So runtime is the container runtime, like Docker or say Cryo. There are a lot of container engine like Mesos, where you are suppose you have an image or a container image or say Docker image. I think you might be familiar with Docker that you want to run in any Docker machine or Docker engine, right? So these engines run to the Docker engine or container engine in general. Okay. Okay, now next thing is there. Let's see. What is next? Yeah, so now we'll be deep diving into the Kubernetes concepts, because we'll be doing a lot of advanced stuff with the Kubernetes, but if you're not familiar with the key or terms, you'll find it difficult to understand. That's the reason I'm covering in this 101 basic Kubernetes session what are the basic things. Okay, so let's go. I think, I mean, it's not a component, but it's the client part. But I want to explain this one even further. Otherwise, you will have issues to understanding. Okay. So, what is kubectl? kubectl is a command line tool that interact with the kube API server. Now you already know what is a kube API server we just discussed, and it send commands to the master node. Like we as a developer, we may send create, expose, run, explain, get, edit, whatever the request I'm sending, that will go to the kube's API server or Kubernetes master node. So you are using kubectl command line to send the request or whatever you want it to happen to the Kubernetes cluster. Okay, and syntax is simple: the kubectl, the command type, name, flag, blah blah blah. Lot of is there. Okay, example you can see. Suppose we are applying, so we have a configuration to create some resources. We will say kubectl apply, then like dash f to the file path. They say my manifest.yml. Now suppose we want to see what are the running services. Now what are the services, pods and all will be coming. Service part, yeah, will be coming there, so no problem. So what says to get the services, just think about that. To get the services, kubectl get services. To get the pods, kubectl get pods. Now see all through the like whatever namespace you have, all that if you want to do, you can give dash dash all namespaces, you will give that. Now these are the things again in our upcoming practical sessions or lab sessions we'll be going through. Just think these are the things there we'll be experimenting later on. So yeah, kubectl command is there. One cheat sheet I want to show. Give me some time so I can show you guys. Okay, because that's a very good one. That's the reason. kubectl. I hope you guys can see the screen. So kubectl cheat sheet. Yes, you can go. I mean, in the document anyway I've mentioned, but for you guys I'm just giving it now. So you can see Kubernetes chips, Kubernetes kubectl cheat sheet. You can see the for bash as whatever you just configure and to configure it here. You can see all the commands, like whatever you're supposed to use your entire lifetime. All the commands are actually in this particular page. This page, let me post the link for you guys because I think that will be useful. Okay. One question I think I saw that when to use kubectl. So we will be using we don't have direct access to any other component in Kubernetes. Okay, we have access to the kube API server via the kubectl command only. You don't have direct access. Think about, you don't have direct access. We have only way to interact with the Kubernetes cluster is via the kubectl. Now, if you are admin, you can of course always log in the master node or worker node, but I'm not expecting you to do that. Okay, you should expect yourself to interact with the Kubernetes. Like after the installation and setup is done, an engineer or developer should never directly interact with the kube proxy. Okay, they should use the kubectl and the configurations. So for example, this Kubernetes manifest file or say this YML files, we write the configuration and execute via the kubectl, create or say execute via the kubectl, then it will or the what you're expecting should be there via the kubectl commands. Of course, the API server or the Kubernetes control manager will check that it's possible or not, it's valid or not, it's available or not, and then it will keep the desired state. Okay, so yeah, you should only use the kubectl and not the Kubernetes proxy. So I want to show you these guys this particular very beautiful this cheat sheet, and I will give the link. Anyway, tomorrow when I share this particular, I think already shared, right? So when I share this document, anyway you will get it. This document will be free for all. I'm not gonna charge you because again I copied this content from Kubernetes official website and other places, right? So I should not charge anything for that. So that I will share with you guys. So no worries. Now let's get back to our session. Okay. Okay, so you guys, I hope you understand the kubectl command importance. This is the only way you should interact with the Kubernetes cluster, not directly via the say SSH and all. You should never do that. And you have the commands and all, you can just refer to the main command screen. Anyway, just don't worry. Anyway, next session onwards, when I show you how to do the cluster setup, how to show the say how to deploy the pods and everything, we'll cover. So no worries for that. This is your basic understanding. That's what I'm telling. Yes, now the fun begins. The pods, right? So pods are the smallest deployable unit of computing that you can create in Kubernetes. Now what the hell it is? It generally refers to one or more containers that you should be controlled as a single application. For example, say you have an application, it's a Node.js application or Python application. For those, I mean, you have the application, and to catch the responses, okay, you need a Redis server, for example. Now the Redis and the application could be in Python, could be in Node.js, can reside in a single pod. But in general, what people do in a single pod, they deploy a single container. But it's fine. Someone want to run two container in a single pod, it's completely acceptable. They can do it. Okay, but you understand that pods are the smallest unit in Kubernetes where you run your containers. Okay, so there's a pod, inside that you run the containers. Okay, I forgot to put a diagram here, but it's fine. Next day I will put it. I will not forget that. So it generally refers to one or more containers that one should be controlled as a single application. The pods encapsulates the application containers, storage, resources as a unique network ID and other configuration on how the container should perform or like should behave. So all the configuration for the container you configure by the pod. For example, see this particular this direction. See this particular configuration part where it's saying what is the API version. Now these are the technical jargons for now. This API version, this kind, metadata, spec, containers, images, ports and all this kind of configuration. In the next session I'm supposed to cover you this all this what this how to write a configuration file, not a single one. How to write pod, how to write services, how to write namespaces, all the single thing, how to write, how to execute, how to perform, how to set up cluster, every single thing I'm going to cover. Okay, step by step. I will see what I think next session will be most probably in the cluster part, but I'll see how much I can cover. So yeah, you can see this is the pod example, and in the pod example itself we are saying what image to run for a container, what should be the port it should be exposed to the public world, outer world or internet. You are controlling a container via the pods. That's what I'm supposed to like what I'm trying to explain. Okay, now to apply, say you have this particular like this all this configuration, right? This one you can write, you can apply via the kubectl. See, kubectl apply, then -f, then the name of this particular file, say sample -pod.yml, you can give. Now suppose you have a URL, but you have the like publicly accessible URL, then you can mention instead of file name, you can mention direct URL as well, and there are a lot of ways you can mention. You can have a like direct file content as well. That will also work. Okay. To know more, there's a link I've given. When I share the document next day, you should be able to use that one to like read more. Anyway, you can go to pods like kubernetes.io and search for the pods. You will have all the details. I've given the same link here. So you understand the pods. Pods are the smallest unit in Kubernetes. Pods are where you run your actual containers, and in the pods you mention like what should be the configuration for the container that you mentioned. Okay, that is very important here. Now the next one is the services. Now I will explain the services of course in depth, but why there is like why was pods not enough? Why the Kubernetes introduced services? The same concept, if you ever actually explore the ECS, you will find the same reason. The reason is that a pods can be terminated for any reason, and if that happens your application might fail if you don't have some way or some mechanism to network level at least adjust it, right? One going now, suppose you have one domain. If you have ever worked with domain, you can give two kind of record to point to the application or application the hosting URL. First is that via the IP you can give the where you are hosting your application, give the IP of the particular instance, and you have to configure the instance accordingly and give the IP for the domain. But if that IP like crash, that instance crashes, that IP will be not available. It will not be able to serve the responses or any request. Okay, so then it's non-serviceable. It will be not used. People will see blank page 504 whatever error it is. They will get they will get angry. Okay. But what if your pod goes down for any reason and there is some way to recover it very fast and quickly and serve the new like any new instance or new resources there, which will give the responses. Like user should be, it will be invisible to users, so user should not be able to see the downtime. They should see application is up no matter what happening in the background for any reason. For example, you have to upgrade the images. You cannot upgrade the image to a running pod. You have to actually like make it deployable, so it will change. It will stop the traffic. It will update with the new image. Then again, it will come back and serve the traffic. For that also, you are for temporarily you are making that out of your cluster, right? So all this complicated situation, if it's a DNS address instead of a particular IP, then it solves your issue. Okay, that was the service does. So it's an extract way to expose an application running on a set of pods as a network service. So it's like this is your this is your service, and this is your pod. So via service like forwarding the response or the request to the pods. So any pod going down, it will create another pod, or like it will like give the instruction, and it will pass on the instruction, and she will see, okay, one pod is missing or something happening, replace another pod. Then the service will check new pod getting added. This new pod IP will get added to the list of this, like list of available IPs, and service will redirect the request to new IP. So service, what it does, it simply check for what are the pods available, and it will redirect the request to there. If one pod is not available, fine. I mean, doesn't matter. There will be new pods which will serve the request. So that's the reason you have a network service which redirect the request to the pods, and it check what pod is available, what is the kind of, you can configure all that. Okay. Now pods are like, again the reason, again I'm just repeating, pods are volatile. This is Kubernetes does not guarantee a given physical pod will be kept alive forever. They can never. Okay. Instead, a service represents a logical set of pods. So it's a list of pods, logical references, and act as a gateway, like your load balancer and your instances. Load balancer give you the DNS. Using that, if the request goes to the normal instances. Similar way, then service is think about it as like in real life cases also, it's a load balancer kind of thing, and again it will redirect the request to the pods. Okay, allowing to send the request to the service without needing to keep track of the which physical pods to actually make up for the service. Like service will automatically determine. You don't have to worry anymore. Kubernetes gives pod their own IPs, own IP addresses, and single DNS name for the set of pods using services can be load balanced across them. Suppose your request coming and say, if you redirect all requests to one single pod, it will crash because it cannot handle all the requests, right? So if you have multiple pods running behind a single service, it can check, okay, what is the load? Okay, this guy is free, this pod is free. Say pod 1 A or pod B is free, redirect the request there. Pod C is free, redirect the request is there. That kind of thing happen via the service. Okay. Now to create a service, you can see already the service example here I'm mentioning anyway. Again, all the technical jargon, API, kind, data, and all that I'll be explaining the next session. Just think that it's one traffic, it's the traffic coming on port 80, and once it's coming to port 80, is redirected to the target port, that is port number 9376. That is what's doing. Okay. And selector is the app selector. What is the name of the pods that is redirecting the request that is doing it. Okay. Now you don't have to worry about all this configuration and all. I'll be explaining in a very greater depth how this configuration work, how can you write configuration, what's supposed to mean, how to select, and all that complicated stuff we'll have in our next session. This session is pure and simple basic components. Okay. Now I think you guys understand what service is. Simply a kind of a load balancer thing. It redirects the request to the instance kind of thing. There instead of instance in Kubernetes you have the pods, right? So now the next one is the volume. Now I will pause for a few seconds and see if there is any question, very urgent question, and I will answer. Okay, you have a lot of questions. It is that you will show practical for in a single session. Giving all theory practical will be tough, and it's only night time, right? So not today, but in upcoming session it will be all practical, because this is why I'm covering the theory first, so that in the next session you will have good understanding of all the technical terms, right? Then you can understand the better the practicals and all. That's the reason. Any other questions? I think One good question here. So what happened if Kubernetes reports to the unhealthy to the master? So one pod is kind of is saying it's unhealthy. So Kubernetes will automatically no more schedule, because even if it's try, the node will be not able to serve the request, right? So it will not serve, or not will not ask to run the any particular workload. It will see what is the next available node available. It will redirect the request there, okay, or it will schedule whatever the resource creation, updation, and everything will there. Okay, let's see any other questions. Can you say it's a way to cube handles? That's a good question. So can you say it's a way to cube handle the load to cover failure? Yes, exactly. Because pods can fail and will fail eventually, right? Because for example, even if you want to update a particular Kubernetes pod, say you have a new image, it need to stop taking requests, it need to update the new image to like get all the changes and all, then it will start the serving applications. For that reason, you have to stop the Kubernetes that pod for a few seconds or minute so that you can update, right? So it's kind of handle to handle all these failures. Okay. And I see. Okay, there are other questions. I'll be coming, so no worries. Let's first cover the rest of the thing. Not much remaining, but stay with me. What are the volume? Now, what are the? I think let me just make it down, and make it smaller. I think it's fine. So, what are the volume? So, volume is in a simple sense is the directory containing data, just similar to a container volume in Docker. If you don't know Docker, is fine. You can learn later, but I will expect you guys to know Docker. So, what is the volume? Volume, if you guys ever use a Linux system, you see mount volume. You see in Linux system, you mount your OS in a volume. You can virtually create the volumes, like physical volumes or virtual volumes, and you can say in this volume I should have my OS related component. In this volume I should have my only data related things, or say my configuration thing. So you can define volumes and you can store the things there. So ultimately it's a directory where you store things. Here volume exactly same thing. The volume in simple sense is directory containing data, just similar to container volume in Docker. Both are same thing. But the catch here is that the Kubernetes volume applies to a whole pod, and a single pod can actually have multiple containers. So in normal case, Docker container, you have one volume for one container. Not many can access all together. But Kubernetes by default, you have suppose two container running, three container, or one container running in a it's available to entire containers. Okay, that's like whatever containers running in the pod, it's accessible to pod altogether. Now using volume, Kubernetes guarantees the data is preserved across the container restart. So any container restart or something happen, it's not volatile, that it will still have the data. It's restart, it's complete fine, it will have the data available when it boots up. Okay, now these are the many types of volume. Yeah, there are a lot of type of volume. So empty directory, host path, GCS persistent disk, now GC the Google part, AWS Elastic Block Store, the block storage, NFS, ISCSI, Flusk, Gluster TFF, then RPD, CPHFs. I never use that one. Git repo, secret I use a lot of time, so you should be. I will have a dedicated session on secret anyway, so that's the reason I'm not too much discussing here. I'm keeping it as only 101, okay, not 1001. Okay, so yeah, secret, persistent volume. Persistent volume is the most important, because suppose you need some data to be stored permanently for maybe future processing, log processing, whatever it is, some database and all, you using some database use cases. So that data has to store persistent, like it should be available even if the cluster gets down. Okay, that kind of mindset if you have, you should use a persistent volume. There are a lot of options. I will not come right now there, but you should think that persistent volume is where you store data permanently. Now, downwards API are there, as Redux volume are there. There's a lot of there. These are the in general, and Kubernetes is adding like new ones all the time. So you should keep an eye what they're adding. Okay, and a very good example I've given, say persistent volume, API version 1, metadata, and just again technical jargon. Just don't think. Look at the few things that I will say that. Say this storage, how much GB, 10 GI, 10 GB. Access mode is read write, host path, like where to actually map in the host path, that is given. That is the most important part. Okay, now just understand it's simple. You're storing data in some directory. That's what it is, and you're saying how much data should be available via the like how much GB data should be available to mount on that you're doing by the volume. For now, think that way. In our future session, we'll go very deep dive and we'll have a dedicated sessions on volume. So we'll cover there. Okay. And let's see if any question before going to deployment for this part. Let's see any questions. Are you going to discuss more about? Yeah. So one question that asked, are you going to discuss more on PB? Not in this session because this is 101, right? I cannot go deep dive to every single thing. 101 will discuss the components. In our future session, I will have the cluster creation, everything. I will have the configuration, dedication, how the configuration write and read out of it, make changes and all. Then volume, networking, all that, right? So in future session, we will cover in depth. Okay. So yeah, volume we have covered. Now the deployment. I think this is another very important part. I think how much remaining? Yeah, namespace remaining. Okay. So deployment is that where suppose you have some 10 pods running. Okay. Now you have 10 pods running. You want to add 2 more, or maybe you want to make changes or update the deployment. All that you want to do, right? You cannot take down everything. You cannot update all together because that might create a chaos and downtime, right? You need to have very good way to do deployment, maintain number of kind of how much replica you have to done and all that. That you do via the deployment. So in definition, a deployment provides declarative updates for pod and replica sets. So how much should be running and how to deploy, that kind of thing. It describes the desired state of pod or replica set in a YML file. The deployment controller then gradually update the environment. Very important, okay? It handles the updates as well, okay? How you want to do it is up to you. There are a lot of deployment policy. I will come in future, like shadow deployment, I think canary deployment. All this are there. We'll be covering the future session. So yeah, so the deployment controller then gradually update the environment until the current state matches the desired state specified in the in the deployment file or in the file that I'm showing here. Okay, so as you can see the app version, API version, apps version 1. Now, if you don't understand what is the API version, all that, in our next session or maybe probably in the next session only, I'll discuss some things about that. Okay, so that you will get used to all these kind of things. So yeah, until the current state matches the desired state specified in the deployment file, this YML file. For example, if the YML file defines 2 replica for a pod, but only one is currently running, extra one will get automatically created. For now, you have 3 replicas running, so 3 identical pods running, okay, to handle the workload. Now, if you do, you're running, right? So that part you can simply mention in the say I want 5 replicas to run. It will automatically create the new 2. Okay. So that's what happens. Now note that replicas managed by the deployment should not be manipulated directly, only via the deployment file. Okay. Now to create a pod, it's actually deployment. So just think, I think I forgot to miss this one. So yeah, simply to create a deployment, run kubectl apply -it, then the deployment file, and that will create it. Okay, this is the last. Okay. One thing got crashed. No problem. So in here we have the namespace, right? So what are the namespaces? In Kubernetes, namespaces provide a mechanism for isolating the group of resources within a single cluster. I think you suppose you don't know what is particular namespace, how to run namespace and all that. Think that there is a default namespace running. So if you don't create a separate namespace, there is default namespace running. Okay. So in Kubernetes, they provide you a way. Suppose for analytics, you want to run a very isolated resources, or you want to maintain like a custom naming resources. For database, you want to have separate names. So that's virtualization. For application, you want to have a called application name for the namespace. You can do all that, kind of do virtual naming for the clusters. You can do that. Using that, you're isolating every single thing. Okay. So a virtual cluster is again a single physical cluster, can be done virtual one. Intended for an environment with many users spread across multiple teams or projects, like DB team working on the database namespace, say application team working with the application related namespace. For say analytics team working with the analytics namespace. This is where you can create namespace and manage that way. Okay, and resources inside a namespace must be unique. Cannot access resources in a different namespace. So of course that's they cannot do. Also, a namespace can be allocated to a resource quota to avoid consuming more than its share of a physical cluster overflow. So for one namespace you are assigning, okay, maximum 2 GB or 8 GB can be used. You can do all this configuration. Okay, now to create a namespace you can run command like this is the file. You just have to mention API version and all, kind is should be namespace, metadata is in where you're giving the analytics. Okay, so or any name you in general have. Now understand that very really well that all this that you have covered, I'll be having detailed each episode. I'll be covering all single thing, how to create, update, delete, how to update the cluster, security, and every single thing. Specifically networking part I didn't cover here intentionally because I will have a very in-depth plan and even create a document also for in-depth session. That's the reason. So that's it, and let's see what we have. So yeah, thank you, and I will see what are the next questions are. So let me quickly move to the normal camera. I hope my normal camera works. I don't know why it's not working. So let's see. Any question? Let me open the questions part. This is what I have right now. You can do not do much. Okay, so there are a lot of questions, and I will try to cover quickly. In an organization, how many K8s cluster will run for each application? Application maintain one cluster. What is the right mechanism used, master and worker nodes for how many application? Okay, that's a big question. I will go one by one. In an organization, how many cluster we should run? So the number of clusters should be based on if you have different client, for each client you should run separately. You should not mix up for the governance, for the best practice I will say. But if it's you have to ultimately run, you can run. It's up to you guys, but should not. Okay, that's one thing. Based on the number of clients, you should have the cluster. Now, if you for your internal application, you might have one cluster, two cluster, or even in the one cluster also you can for different namespace you can divide it, or you can just have a separate, say for staging you have one Kubernetes cluster, for production you can have different Kubernetes cluster. Both are possible based on budget and the requirement you have to define. Now what is the right mechanism to use master and worker node for how many application? So master node, again, you are not running any workload, you are just defining. You can, if it's the workload is really huge, then only you have multiple master node. Otherwise one master node is more than enough. You usually have more worker nodes where your workload is increased, you have more worker nodes getting added. That part, how many and to run, it always depends on the how much workload you are run. If you have a very huge workload, you will be more number of the clusters, or sorry, no, not clusters, the worker nodes, and you have less workload, then you have a less number of the worker nodes. um, Please let us requisite for this next. So next practical session, you should have your Kubernetes install. I will share the installation step anyway, so no worries. But prepare with at least the Dockers and if possible, install the kubelet and kubeadmin. Okay, this should be enough. Again, I will do. Tomorrow when I share this document, I will add the prepare for the next session where you should be what are the things you require for the next session. That I will add. Okay, so no worry, I'm adding there. That you don't have to worry anyway. Nice introductory session, Sandeep. Thank you, Sainath. Then containers can think as the smallest unit running in pod. Exactly, that's the smallest unit running in a pod. Right. You guys learn it really quick. Good. Okay. What is next? That one is in the next chapter. Okay, I think I have to go up to understand the question. Are you going to discuss more on PV? No, it should be, I think, maybe fourth or fifth one. The next one will be cluster creation, how to use the kubeadmin, kubectl command, installation on 3 worker nodes. I'll be using most probably EC2 to install and configure and connect. All that I will do, and I will try to explain the Kubernetes configuration file so that you will be feel more confident how to work with those. That will be my goal. Okay. And other question, let's see. EKs I will definitely cover. Don't worry. Mm, Sir, GKs, AKs, EKs, what is the best for learning? Again, that should be depend depend on what cluster you're currently, or what cloud you're learning, or your new work you're doing. Suppose you're working in AWS, then of course go for the EKs. Suppose you're working in the Azure, then of course go for the AKs. Okay, so it depends, or similarly GK. That's fine. Yeah, we say feel free to check out later. So is Giri saying what is dash if? Dash if actually refers to the what content you are referring, or what is the configuration path. That's it. I think yeah. Srinath say the right thing. Okay. Yeah. So so yeah, my daughter, what happened? She got stomach problem, fever, and Zukam and Kazi all together. That's the reason. Last time, previous day, actually supposed to do this session, but my wife got fever, so I said to take care of her and thought, okay, next year I will do that. So hopefully, even see, I didn't able to set up my camera. I forgot to charge the camera, even my DSLR one. So that was happened, unfortunately. But it's fine. Sometimes things might not work as per what you want, but you have to simply. Oh, now my thing, the camera working, but it's very slow. Maybe I will simply go with my normal camera. Fine. Okay, so now it start up, but it's fine. Yeah, she's doing good. My wife, I think last call happened, she's doing good, but I will come back tomorrow morning to her place and see if everything is fine or not. Any more questions? I will simply Sindas, will it be uploaded to your channel? So yeah, Joad, it is right now getting recorded in my channel. It will be available. I think within next 15 to 20 minutes, you can see the entire from beginning to end. Like entire video will be available. No worries on that. Okay. And this document, if you guys are not connected with me in LinkedIn, do connect in LinkedIn and follow me there, because there I upload the document. Usually I will try to upload the document reference in this particular video's description section, or in the comments as well. Okay, so no worries on that. Both I will okay. Damn. One thing that teach me how to write Kubernetes YAML file with all minimum aspects. That will be the next week goal. Okay, how to write things, how to do understand environments and all these things. Because we'll be setting up a cluster, we'll be installing everything. We'll be understanding the basic component, how to write a YAML file. That out anyway. So before even going for the writing YAML file, if you don't know, in my channel, if you go search, you will find YML crash course. Do go through that. I will give the link in description as well as in the comment, because that is the reason, that is the sole reason I covered that that YML crash course, so that I can teach you all this configuration adding in Kubernetes. That's my pre-planned thing. Okay, people thought why you have done that one, so that was the reason, so that in the Kubernetes or any other places where I'm writing the configuration file, you should have a very good idea why I'm writing, how I'm writing it, how I'm referencing objects, mapping, or say arrays and all that. You should be able to understand that. So refer to that video first. I'll give the link in maybe after 1 hour and all. Okay. So yeah, it says that cryo is different. It's just simple another continuation system, just like Docker, but of course it have its own pros and cons. You have to go through that and run that, use that to understand the differences. Any other questions? I think that's most of the question for now. And thank you guys for staying this long. I know my camera didn't work till now, but now there is no point around the camera. So still saying this long, going through all the session, asking question. I do really appreciate if you don't. I mean, I think you guys already subscribed, but if you are not subscribed yet, do subscribe to the channel. Like this video, share this video with other people whom you think that they will be get benefited my videos. I make videos on most cases weekends. I was supposed to make normal days also, but with family and other workload is it's kind of very problematic. I'm thinking of how I can manage all that, but soon I will find some solution anyway. Renting or maybe purchasing one place where I can make my dedicated studio or something. This is good, but you need to get improved all the time. So yes, thank you guys for staying all this long. It's an 1 hour 30 minute session. Again, thank you very much. All your queries you can send me in normal LinkedIn messaging or in this video's comments wherever you find it useful. I will